In this work, we present a system to infer and execute a human-readable program from a real-world demonstration. During the demonstration, our perception system will detect objects and their poses, ultimately predicting a program for the robot to reproduce the demonstration. The execution system operates in a closed loop, with the perception system to run the program and replicate the demonstrated arrangement. Should anything be amiss in the predicted program, the human demonstrator can repeat the demonstration or edit the program directly. Our system consists of a series of neural networks. To observe the demonstration, we use a pipeline of 3 networks. The object detection network perceives the poses of objects. Built from a convolutional neural network, it predicts the locations of object vertices in image space. After detecting object vertices, a second network infers object relationships. The program generation network consumes observed object relationships and outputs a plan to reproduce the observed arrangement. Finally, the execution network guides the robot to reproduce the demonstration. Following the program, this network operates in a closed loop with the perception networks to select the correct pick and place operations. Using a structure inspired by convolutional pose machines, the network resolves pose ambiguities by multiple stages of processing. Perception networks are trained via domain randomization using only synthetic images. To increase applicability to new visual settings, we predict an image space rather than a fixed world space. Despite never observing a real image during training, the perception network reliably detects the bounding cuboids of objects in real images, even under severe occlusions. Together, the set of object detection and relationship networks define the vocabulary of the human-readable programs. In our implementation, we trained object detectors for several blocks and a toy car. We trained the relationship network for 2 physical arrangements, above and left of. We test the system in the real world on pick-and-place stacking demonstrations using a Baxter robot. In this clip, the operator shows a pair of short cube stacks. The system predicts an appropriate program. During execution, after correctly placing the blue cube, the robot fails to place the yellow cube on the green cube due to an error in depth estimation. However, because the execution network integrates perception of the current state, the system automatically recovers. The command is issued again, and this time it succeeds. In this final clip, we demonstrate stacking a non-cube object by placing the toy car on the yellow block. Despite being trained to recognize only a blocky cartoon of a toy car, the perception and execution systems perform the stack correctly. Going forward, we continue to study the use of synthetic training data for robotic manipulations. Thanks for watching.